Okay. Okay, can you all see my screen now? Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
So let's start today's business. So you are welcome to the class. I greet you, and then we are going to continue our journey where we are trying to learn the concept of differential equation. So we call it elementary differential equation because we are trying to take a look at this problem called differential equation and establish some facts. So we are going to proceed now. So looking at this now, today we're going to consider higher order linear differential equations. If you look at equation 1, I believe all of you can see equation 1 very well. Hello, can you all see my screen?
Yes, sir.
Okay, let's proceed.
Yes, sir.
Now, if you look at this one now, you see that
Yes,
the highest order here is what? Is n, isn't it? And if we have it to be n now, we can call this one, we can call this one n order. You will notice that it has coefficients a0, a1, up to an minus 1 and an. All this one, they are function of x. They are function of x. Now let's take a look at number 1 now. Number 1, in equation 1, a0 of x, it must never be 0. Because by the time an of 0, a0 of x is 0, you will notice that nth order will disappear, right? So in that case, we have the problem to be n minus 1th order. But what we are looking for is nth order. So the highest order now is n.
Sir, I can't hear you clearly.
Okay. Okay.
Great.
What about now? Can you hear me clearly now? Can you hear me clearly now? I think you can hear me clearly now.
Yes, sir.
So now let's consider another point again. All the coefficients. Oh, no.
Yeah.
Okay. What about like this? I think it should be better like this.
Still not clear, sir.
I think it's okay now. Can you hear me clearly now? Okay, I believe you can hear me clearly now.
Yes, sir.
So let's proceed.
Yes, sir.
So in this case now, let's consider a0, a1, an minus 1, all the coefficients. What we are trying to say that all the coefficients that they are constants. And what do I mean by constant? It's either it is 1, 2, 3, 4. Even it can be function. A0 of x can be sine x. It can be x squared. It can be any variable. So that is the second point now. So what we are trying to say now is that the coefficient of the derivative, they are function of x, or perhaps they are dependent on the variable x. And don't forget that in this case, the independent variable is what? Is x. Okay. Then number C, equation 1 is now called the general linear. Now, why do we call it general? We call it general because it has nth order. N can be integer. It can be 1, it can be 5, it can be anything. So we are going to call it nth order. And at the same time, we're going to call it linear because we are very sure that all the coefficients, which are a0, a1, a2, up to an, they are all constant or they are function of x. Now, let's consider the two cases I've introduced to you before now. In this case, look at our b of x. If our b of x is 0, what does that mean? It means that we are dealing with homogeneous. So we can call it general homogeneous and we call it linear because we know about the problem before. Now, let's take a look at another thing again. In equation 1, let's say in equation 1, our b of x is 5. It can be 2, but not 0. What I'm trying to say that here, this b of x, if it is 5, it is 10, it is anything like constant, or perhaps it is a function of x, then that makes this equation 1 to be non-homogeneous. So is there any question on this before we proceed? Hello, class. Is there any question on this before we proceed?
No, sir.
Now, thank you very much. Now, let's take a look at example 1 now. Look at this question number 1 now. In this case, we are going to call this one third order. Why? Because the n here is what? Is 3.
3.
Yeah. And we're going to call it linear. Why are we calling it linear? Because all the coefficients of the derivative, they are constants.
Yes, yes.
Now, we're going to call it constant coefficient because we are having 1, 3, 1, and 1 to be the product. So we call it constant coefficient. And we're going to call this one non-homogeneous because of x squared. Because of x squared. Now, let's take a look at example 2 now. In example 2, we are going to call this one variable coefficients. The reason why we are calling this variable is because we have x squared multiplying the derivative.
Okay.
Don't forget that we cannot call this one non-linear because there's no way we are having dependent variable multiplying the derivative.
Yes.
So we are going to call it variable coefficient. And at the same time, it is homogeneous because everything is equal to what? To 0.
0.
Now let's take a look at example 4. We call this one fourth order. And not only fourth order, it is indeed linear. And indeed, it's a constant coefficient. And it is non-homogeneous because we have x squared plus 1. Now, you will now see that x squared plus 1, you know that is a polynomial, right? Polynomial of what order?
Degree 2.
Order 2. So we're going to solve a problem like this today now. Now, let's take a look at example 4 and 5 now. Example 4, they are the same thing. Look at it very well. The only difference is that the condition. Look at number 4. You will notice that we have x of 0 is equal to 1. We have x derivative at 0 is equal to 5. Don't forget that in the case of second order, you know, if you have to solve second order, you need to integrate twice, isn't it?
Yes, sir.
And by the time you integrate twice, you have two constants. For you to find the two constants, you need two conditions. So for us to solve second order, we will need just only two conditions. Now look at the two conditions. Now you notice that the first one is specified at 0. The second one, it's also specified at what? At 0.
Yeah.
Because the two conditions are specified at 0, then we are going to call this one initial value problem. That is why you can see an initial value problem. Because the two conditions that we need to solve the problem, they are specified at 0. Let's take a look at number 5 now. Look at number 5. We have the first condition at 0. We have the second condition at 5. Look at 5. That is x prime of 5. Oh, there's a mistake here. Please, sorry. It should be y of 0. Please take note of that. Here, it should be y of 0. Are we together?
Okay.
This should be y of 0. Y of 0 is 1. Then y prime of 0 is what? Is 5. And the second one is, you know the reason is y. Y is the dependent variable, right?
Yes, sir.
And then x is the independent. X is 0. So please take note of this. So we have it to be like this. So we call this one second order linear. But we're going to call this one boundary value problem. Why? Because the two conditions are specified at 2 points. That is at 0 and at 5. Now let's take a look at
Sir,
yes, speak.
can we call the number 4 boundary value problem also?
No, we are calling it initial because
Initial.
it's initial. Number 4 is initial value problem because the two conditions are specified at 0. This is x equals to 0, x equals to 0.
I thought it says 1. Y of 0 is supposed to 1.
Yes, y of 0 is 1. Then y of 0 is what? Is 5.
Okay. What
So
of number
because
5?
the two conditions at 0, 0, then we call it
Okay.
initial value problem. Then this one, y of 0 is 1. Then y prime of 5. This means that 5, if x is equal to 5 in this case,
Okay, sir.
equals to 5. So we call it boundary value problem. So let's go now. Now, the next thing that you need to do that, when do we know that there's a solution? If you look at this one very well now, you know, this is nth order, right? Nth
Yes.
order, and it's of general. And it's
Yes.
ordinary differential equation because we have only one independent variable now. How do we know that this kind of problem has a solution? Now, let's take a look at the theorem now. The theorem, we call this theorem conditions for the existence of a unique solution. You know, the unique solution we're talking about here is talking about a solution in such a way that there is no other solution again. Even if I thought there is any other solution, then the two solutions, they are the same. Now, let's take a look at it now. For us to be able to justify this, it has to do with the coefficient of x. Okay? I can say, okay, I think you can hear me clearly now. Okay. Now, let's take a look at the statements now.
Yes, sir.
If we have the function a0, don't forget that a0 is a coefficient, right? A1
Yes.
is a coefficient. You know, that coefficient, it can be 1, it can be x, it can be sine x. Are we all together?
Yes, sir.
Cool. Now you now see that whatsoever the nature of the solution may be, we are still going to use the same points that we'll be using. Do you remember the points? Continuous and what? Boundedness. Are we all together?
Yes, sir.
Yes, sir.
Yes,
So
sir.
we're still going to use the same point here that all the coefficients, they must be continuous. And don't forget that that statement is not correct. They must be continuous in a particular domain.
Domain.
Exactly. So look at it now. We now say that if the functions a0, a1, an, bx, they are continuous function of x in the interval alpha and beta. Here, alpha and beta, they are what? They are real numbers. Are we together now? It can be 0 to 5. Just like in the case of boundary value problem. Look at it. Oh, here, the alpha here is what? Alpha is from 0 to 5. Alpha is 0. Beta is what? Beta is 5.
5.
So that's what we are talking about. That in the interval alpha plus beta, and look at it, a0, it must not vanish, which means that a0 must never be 0, because by the time a0 is 0, you notice that we will not be able to know the highest order. So that is why we are saying here that a0 of x, it must never be 0. That's why we are a0 does not vanish at any point of that interval. Then the initial equation admits the solution of y is equals to what? F of x, which is the solution. But one thing is this: if you now put, in this case, now y is the solution, right? If you put x0 in the solution, if you differentiate the solution and you put x0 in it again, if you differentiate the solution twice and you put x0, then it must give us a statement that are the same. So that's what we are trying to say. And where x0 is a point of the interval alpha, beta. So if you look at your lecture notes, this particular theorem, it's somewhere in module 4. You will see the module, you will see there in module 4, module 4, unit 1. So that's what we're talking about the existence of solution of nth order general differential equation. But that's not all. Let's take a look at this problem now. Let's look at this now. Let's look at this example. In this case, we have a particular solution to be 3 exponential 2x plus exponential minus 2x minus 3x. We are asked to prove that this is a unique solution of a particular initial value problem. Look at the initial value problem now. Second derivative of y with respect to x minus 4 of y is equal to 12x. Is this problem homogeneous or non-homogeneous?
Non-homogeneous.
Non-homogeneous, thank you. Now look at it. Look at the two conditions now. Y of 0 is 4. Then derivative of y at 0 is also 1. Now, if you look at equation 1 now, is this boundary value problem or initial value problem?
Initial value.
Initial.
We have the two conditions specified at 0. Now, let's look at the solution now. This is the solution now. Let us differentiate the solution. If you have to differentiate y with respect to x, how do you differentiate exponential? You differentiate the power, which is 2x, right? Then you have 2 times 3. Then that will give me what? It will give me 6. Are we together? Then we have it to be 6 exponential 2x. Then minus, if we differentiate minus 2x, that will give us what? It will give us minus 2. Then minus 2 times this will give minus 2. Then if we differentiate minus 3x, minus 3 times x, it will give us minus 3. So we have dy dx to be this. Now let's go again and differentiate the second time again. Why do we need to differentiate the second time? Because we are dealing with second order. So 2 times 6 will give me 12. Then exponential 2x. Then here, minus 2 times minus 2 will give me plus 4. Then exponential minus 2x. Then if you differentiate minus 3, it will give you what? 0. So let's substitute equation 2 back to equation 1 now. Let's start now. Look at the first one now. This is the second derivative, then minus 4. Multiplying by ordinary solution y. Are we together now? Then the next thing is this, we expand this. Minus 4 times 3 will give me minus 12, then exponential 2x. Then minus 4 times exponential minus 2x will give me minus 4 exponential minus 2x. Then minus 4 times minus 3x will give me plus 12x. Now look at this, you see that this one will cancel this, this one will cancel this. What do you have? You have 12x, which is 12xa. So which means that the solution actually satisfies the problem. Now let's take a look at the condition. What about the condition? What we are trying to show you is that if you put a 0 in the solution y of x, which is this one, 3 exponential 2x plus exponential minus 2x minus 3x. So we have it to be what? 3 exponential, then 2 times 0, then exponential minus 2 times 0, then minus 3 times 0, then we give me what? We give me 4, which is the condition that we are giving here. Let's take a look at another one again, the second one. Y prime of 0. Before we do y prime, what are we going to do? We are going to use this one. We are going to use this first derivative. So that means that it's going to give me 6 exponential 2 times 0 minus 2, exponential minus 2 times 0, then minus 3. Then this one will give me 6 minus 2, then minus 3, then will give me 1, which is correct. Are we together now? But what we are trying to show here is that the solution of a second order, it must satisfy the problem, and at the same time, it must satisfy the condition. That is the point. So whatsoever you want to come up as the solution, it must satisfy the problem and the boundary condition or the initial condition. So let's take a look at key point number 2 now. You know, we've talked about the existence of solution where we actually emphasize on the coefficient, that the coefficient must be continuous in a particular domain, which is alpha comma beta. And in such a way, then we explain that one. Now let's take a look at linear dependency and linear independency now. Here, there are two different things. There are two different things. How do we understand it now? Let's assume that we have two solutions, which is y1 of x and y2 of x, and they are the solution of a particular differential equation. Now, how do we know that they are dependent? Now, look at this now. If one solution is a constant, multiplying the other, that is when we know that two solutions, they are indeed dependent. I will explain this one very well. In fact, I'm going to use two concepts to explain it. But let's first of all look at the concept number 1. Concept number 1 is saying that two solutions that are dependent on one another. If one solution is a constant, multiply the other. Let's say, for instance, now, a primary school student, you will notice that that primary school student is actually dependent on what? On his parents, isn't it?
Yes, sir.
It's dependent on the parents for food, for shelter, for clothing, and some other things. Now, what does it mean? It means that there is a particular solution that the primary school student is looking for. And that solution is a multiplier of what is coming from the parents. Let me explain to you again now. Let's say we have particular constant C1, and that C1 is not 0. But before I proceed, let me zoom something and show you something. Let me zoom my screen and show you something. Can you see my screen now? Look at this now. Can you see this one? C1 multiplied by Y1 plus C2 multiplied by Y2, it must be equal to 0. Do you remember this? I think I've explained this one before. That is when I was talking about superposition of solution. Thank you very much. That is why I'm saying that even if we have C1 to be a solution and you have a particular constant, if you multiply by it, you have second solution, you multiply by constant C2, that it will satisfy the problem. Because the problem is equal to 0, then this one is also what is also equal to 0. So this is what I'm going to use to explain this now. So let me go back now. So look at this now. In this case now, we have a solution Y1. And in this case, the solution Y1 is now equals to minus C2 over C1 multiplying Y2. Let me explain how I obtained this one. Let me come back to this expression. Look at this now. Look at this now. If C2, Y2 should go to the other side, what do you have? You have C1, Y1 is equals to minus C2, Y2, isn't it? Then by the time you divide both sides by C1, you will now have Y1 is equals to what? Minus C2 over C1 multiplied by Y2. Okay. That is what we are talking about. Look at it now. Okay. Can you see that now? So when do we now know that two solutions, they are dependent on one another? They are dependent because primary school student is depending on his parents. But a university student, they are not, most of university students, they are not dependent on their parents. For instance, now look at me now. I should not tell you that I'm dependent on my parents. Are we together? So what does it mean?
Yes, sir.
It means that the difference between a primary school student and myself is the fact that there is a constant multiplying the second solution of primary school students. But in my own case, there is no constant multiplying. In fact, I've lost my dad and my mother. So why would I be depending on someone that I've lost? Do you get the point?
Yes, sir.
Do you get the point now? So why would I be depending on my father and my mother when they are deceased?
Yes, sir.
So that is the point now. So the way I normally explain to my students now is that before I normally use my father, but now my mother has joined the system. So, so that is the point now. When I'm teaching this to my students, I always use this one so that they should know the difference between linearly dependent of two solutions and linearly independent. So in this case now, look at it now. So we're having a solution Y1 is equals to minus C2 over C1 multiplying Y2. Now let's take a look at the point now. Point number 1. Do you know that in this case, C1 can never be 0? Just like I've said there that C1 should never be 0. Even if it's 0, you know, this one will give you math error. Do you know?
Yes, sir.
So it should never be 0. So, but C2 is what is 0. Now, look at this one now. By the time C2 is 0, do you notice that everything here is equal to 0?
0, yes.
So if everything is 0, what does that mean? It means that it is only Y1 that we know that is 0. we don't know anything about y2. We intentionally fixed y2 to be 0. Do you know the reason why we fixed y2 to be 0? Because we've said C2 is what is 0. And C2 is a multiplier of what? Is a multiplier of y2. Can you see it here now? Can we see there? So
Yes, sir.
if C2 is 0,
Yes.
you know that we are stylishly saying that we don't know anything about y2, but we are trying to force y2 to be 0 when we say the multiplier is what is y2. So in that case, y1 and y2 in that case, no, in this case now we only know y1, we don't know anything about y2. Then we say that the two solutions, they are dependent on one another. In that case, primary school students should not get married. That is the point. Are we together now?
Yes, sir.
In fact, let me even tell you another one biblically. If you are a Christian, don't get married until you are working. Because if that is the case, your husband is not working because he's a Christian, your wife is not working because he's a Christian, what does that mean? It means that you are a dependent on one another, and it's going to lead to a serious problem. So we cannot present such a solution. Although it's a solution, you can get married is a solution. But there is going to be a kind of chaos because the two solutions are dependent on one another in the sense that it is only one that we know. And that only one we know is the fact that you are a Christian. We don't know the other one. Now, let me now explain to you better now. In such a case, y1, y2, they are dependent on one another. Let's look at it again. Minus C2 over C1 is a constant that is multiplying y2. Are we together now? Then look at the third one.
Yes, sir.
C2 is what? Is 0. So that is how we know that two solutions, they are dependent on one another. But reverse is the case. Let's take a look at the reverse now. Reverse is, in this case now, if y1 is a solution and y2 is a solution now, then we have C1 y1 plus C2 y2 to be 0. Is only satisfied by the choice of constants. In this case, C1 is 0, C2 is 0. And we say that the solutions are not constantly multiplying of each other. Then we can say that linearly independent in the sense that the two solutions, they are not dependent on one another. Are we together now? Let's solve example number 1. Let's solve example 1. Let's solve example 1 now. Look at this now. We have solution y1. Now, before I proceed, you know, I'm even saying two solutions. Do you even know this one? I'm saying two solutions. Let's imagine that we are solving second order. Are we together?
Yes, sir.
Are we together?
Yes,
Let's
sir.
answer that we're solving second order now. You know that we are going to have two solutions. Before I proceed, let me quickly jump to page. I'm coming back. Let's look at this problem. Can you see my screen now? Can you see my screen? Hello,
Yes,
can you see my screen? Remember that we solved something like this the other time. Look at it now.
Yes, sir.
Yes, sir.
In this case, you know, we have auxiliary. Aha. Now look at the auxiliary. The auxiliary is what? 4 over 3, which are the M1 and M2. Do you know that in this case, we're having two solutions here? Who can tell me the first solution? The first solution is what? A T exponential 4 over 3t. That is solution number 1. Look at another solution 2. B exponential 4 over 3t. So you can understand that the solution we are having here is a combination of two solutions which are linearly independent. Let me explain to you better now. Everybody, let's look at this one now. Let's look at this problem now, which I will still explain very well. In this case, by the time you assume A exponential mx, you do that, you find your auxiliary, then you know this is a quadratic, right? You solve the quadratic. If you solve the quadratic, you know you have 1 and minus 2. Now look at this one now. Do you know that these are the two solutions? This is solution number 1, which is A. Look at solution number 1. This is solution number 1. And this is solution number 2. Are we together now? So that is actually what I'm talking about, that we can have two solutions. But the point I'm trying to show you now is that if you have two solutions, are they dependent or they are not dependent on one another? So let's look at this now. Back to the example now. Here, we have two solutions now, sine square x, and we have 1 minus cos 2x. These two, they are the solution to a particular second order ordinary differential equation. Now, the point now is this, we should check. These two solutions, are they dependent on one another? Or really, Antayo, please take care of your side, okay? Are they dependent on one another or they are not dependent on one another? Now, let's look at the solution now. Before I proceed, I'm going to introduce something called Wronskian. Wronskian is actually a name of a person who discovered what I want to introduce to you now. Let's say we have the two solutions now. Can you all see my screen very well? Now, look at it now. Where do we know Wronskian? We say Wronskian of y1, y2. Don't forget that y1 and y2, they are actually two solutions. Can you all hear me clearly? Can you hear me clearly? Hello, can you hear me clearly? Hello, can you hear me clearly now? Hello, can you hear me clearly? Hello, students. Can you hear me clearly now?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, let me proceed now. So if we have two solutions now, let's find the Wronskian of the two solutions now. Look at the way I write it. Wronskian of y1, y2. Don't forget that y1 is a solution and y2 is also what? A solution. Now, do you know the next thing is that I will find the determinant. The determinant, I'll put the solution y1 here. I will put the solution y2 here. Then I will differentiate the solution y1 with respect to x. I will differentiate the solution of y2 with respect to x. Then I will find the determinant. Is there anyone of you that can remind me the determinant of A, B, C, D in a matrix? Hello? Hello, are we together? Hello, are we together? Hello, are we together?
Yes, sir.
Now,
Yes,
I'm
sir.
talking about determinant in matrix. I'm talking about determinant in matrix. Let me share my screen. Okay, now, can you all see my PowerPoint screen now?
Yes.
Yes, sir.
Now, I'm talking about, let's say we have Wronskian of y1 and y2. Now, I'm talking about, let's say we have y1, then comma y2. Y2 then is equals to, now here we are talking about matrix. Let's say we are talking about our 2 by 2 matrix now. Look at it now. You have this one to be A, this is B, this is C, this is my D. Now, everybody look at this very well now. That is not all. I need the determinant. The determinant, okay. Now, who can tell me this one is equal to what? This expression is equal to what? What is the determinant in matrix?
AD minus BC.
BC.
AD minus what?
BC.
Minus BC. Can you all see clearly now? So we have
Yes, sir.
it to be AD minus BC. Now let's go back to the problem we are solving now. Let's go back to the problem. Then we now focus on the determinants now. Now, what is the determinant here now? What is the determinant? Who can tell me the determinant here?
Y1 function of x, y2 function.
Minus
Multiplied
Minus y2.
derivative of y2.
no, you are wrong. You are wrong. Y1
Y1
multiplied by
y2
y2
prime
minus
y1 multiplied by y2.
Now, thank you very much for that cross answer. Now, in this case, now, if the Wronskian is not equal to 0, then that means that the two solutions, they are linearly independent. Are we together?
Yes, sir.
So if
Yes,
the
sir.
Wronskian, by the time you find the determinant is not 0, then that means that the two solutions, they are linearly independent. Now, let's go again to the second case. If the Wronskian now of y1, y2, if the Wronskian is now equal to 0, then it means that the two solutions, they are dependent on what? On one another. So let's imagine that in the exam, they ask you to differentiate between linearly dependent and linearly independent solutions. So you can see now that we have 2 points to explain it. You can say that you can use the first point here to explain. that two solutions are dependent if it's only one that is 0, just because the constant of the second one is 0. Do you get the point? You know,
Yes, sir.
we have y, okay, so let me proceed now. So let's find the Wronskian now. So look at the two solutions now. The Wronskian now, the solution is what? The sine square x. Look at the second one. 1 minus what? Cos 2x. You know, these are the two solutions that we're given, right? So let us differentiate sine square x. How do we differentiate sine square x? Now, it's very simple. Let's look at it now. You know that sine square is the same thing as sine x times sine x.
Yes.
So let's use product rule. Product rule means that you keep sine x, you differentiate the other. Plus, you keep the other, you differentiate the other. Are we together now? So
Yes,
this
sir.
one will give me what? 2 sine x cos x. So that is how I obtain my derivative there. Don't forget that I'm differentiating y1, and y1 is what? The sine square x. So I'm differentiating y1. Now let's go to the second one again. 1 minus cos 2x. Then I want to differentiate 1 minus cos 2x now. Look at it now. Y is 1 minus cos 2x. If you differentiate 1, what will you have?
0.
Then if you are to differentiate cos 2x, what do you get? Don't forget that you first of all differentiate the contents. If you differentiate 2x, you have what? You have 2. Then 2 will come outside. If you differentiate cos 2x, you have what? You have minus
Sine
sine
2x.
2x. So minus times minus, then you have plus 2 sine 2x. So in case you didn't remember, so please look at, but I will send this lecture notes. You will see the concept here. Can you see the concept? Look at what I put down here. I said differentiation. If you differentiate sine x, you have what? Cos s. If you differentiate cos s, you have what? Minus sine x. So that will help you. So now look at it now. So let's find the determinant now. How do you find the determinant? We now say sine square x multiplying by what? 2 sine 2x. Then minus, you will differentiate the other diagonal. And that will give you 1 minus cos 2x multiplying by 2 sine x cos x. So look at this now. We have this expression now. So by the time you expand this, you have 2 sine square x, then sine 2x. Then minus, we need to expand these brackets. You know, minus will still come outside. Then you have 2 sine x cos x multiplied by 1. We give you this one. Then 2 sine x cos x multiplied by minus cos 2x. We give you this one. Are we together?
Yes, sir.
Is there any question or no question? Okay. Now look at the next thing now is this. I will multiply both sides by minus 1 so that I can expand the bracket here. So minus 2 sine x cos 2x will come here. Then minus times minus will give me what? Plus. They will give me 2 cos 2x, then sine x cos x. Now, do you know that there's a problem? There's a problem. I need to use what is called sum and difference identity. Now, let's look at this now. Addition of sine. What is sine x plus y? Hello, students?
Sine x cos y plus cos x sine y.
Okay. Okay. Now, what is sine x minus y? What is sine x?
Sine x cos y minus cos x sine y.
How do you remember? Joshua, how do you remember this? Can you share with the class how you normally remember? Joshua, Raphael.
Yes, sir.
How do you normally remember? Who responded the other time?
I responded, sir.
Read one, tell your right.
Sir?
How do you normally remember this?
Sir, it is Cramer's law. Cram.
Deborah, how do you normally remember?
We're taught in cocosin and cos is cocosin.
Cos. Okay, let me share with you. In the case of cos, you expand directly.
Yeah.
Look at it. Cos. Are you getting me now? In the case of cos, you expand directly. Then you now change it. It now be sine. You know, in this case now, you didn't change the trigonometry. Then you need to change the sign.
Yes.
So, in this case now, cos x plus y will now give you cos x cos y. Then it will not be, because you didn't change the cos, then you now need to change the sign. Then sin x, sin y. Then in the second one, cos x minus y. That will give you cos s cos y. Then you need to change the sign. Minus will change to plus. Then you have sin x, sin y. Then let's go to the family of sine now. In the case of sine is the one that is following cos. So in this case, you have to exchange it. So it now be sin s cos y. Then in this case, the sign, the positive will not change. It will remain the same because you've changed the trigonometry already. So you now have sin s cos y, then plus cos x. Then for the minus too, you know that you still have the same thing. Minus, minus. Then you have sin x, okay? Then in the case of tan, you just do it like as if you are doing expansion, tan x, tan y, then the positive sign will remain. But the denominator, it will be minus. It will be 1 minus tan x, tan y. But in the case of tan x minus 1, tan x minus 1 will not be tan x, just expand that with tan x minus tan y, then divided by, then the sign will change. Are we together? So now let's go back to the problem now. Let's look at now sin x plus x now. Sin x plus x will now give us sin x cos x plus cos s sin x, which is same thing as what? 2 sin x cos x.
Yeah.
So let's go back to our problem now. That means that in our problem now, which is this one now, you now see that everything here is not the same thing as what? Everything is the same thing as sin 2x. Do you agree with me? Everything here is the same thing as sin 2x. Now look at this one again. We have 2 here. We have sin x, we have cos x. So 2 sin x cos x will also give me sin 2x. So look at this one. I can answer that. Wronskian of y1, y2 is now equals to what? 2 sin square x sin 2x, then minus sin 2x, then plus cos 2x, then sin 2x. Now I can factorize. Look at it. What can I factorize? I can factorize sin 2x.
Yes.
So sin 2x will come outside. Then by the time it's come outside, then you have sin squared x minus 1. Then you have this. Now you now see clearly now that I'm coming. Okay. So you're having 2 sines. Okay. So now the next thing now is that if you look at this very well, you now see that we can actually see that we can match this together to give us look at this one. If you expand this,
plus cos square s.
do you know that sin square x? If you look at this, let me expand. Look at this. Sin square x plus cos square x is equals to what? 1. Then if you rearrange it, you see that you're having 1 minus 1, because this one can join this one. Then you have it. Then you know that 1 minus 1 will give us, will give you 0. Then you have it to be 0. So since the Wronskian is 0, what does that mean? It means that two solutions that what? They are dependent on one another. They are dependent on one another. They are dependent on one another. That is what it means, because the Wronskian is 0, then they are dependent on one another. So let's now proceed now. So in our last class, we focused on a problem like this, and we call this one homogeneous. And I said, if you want to solve it, just assume that your y is what? A exponential mx. In fact, you may not even write a. You still get it. So you can just write, you can assume your solution to be what? Exponential mx. Are we together now? In some textbook, they just said that let's assume exponential mx. So if you differentiate the first time, m will come down, right?
Yes.
If you differentiate the second time, you have m squared. Then by the time you return everything, equation 2, you substitute back into equation 1. Then you now have your expression to be what? A. Look at it. This A is still here. Then you have it. A. Then you have this expression. Then what's the next thing is that we can factorize. What we're going to factorize now be A exponential what? Mx. Then into brackets A m squared plus bm plus c is equal to what? 0. And I told you last, I said there are 3 things involved. But out of all the 3 things, we know that A exponential ms is the assumed solution. So if it is the assumed solution, it can never be 0. But the other one, which is am squared plus bm plus c, is equal to what? 0. And I said this is what we call auxiliary equation. And if you are to solve the auxiliary equation, there are three things involved. Based on our knowledge on quadratic equation, that if b squared is greater than 4ac, it means that we are going to have two different solutions that are distinct. And if there are two and they are distinct, it means that we can have the word alpha and beta. So how do we now get the solution? We now say the solution is what? A exponential alpha x plus b exponential beta x. Now the second case is if b squared is equal to 4ac, it means that the two solutions that were they are equal. If the two solutions are equal and we are looking for linearly independent solution, we need to multiply one of the solution by x. Are we together? Do you notice that if now let me share my screen with you now. Let me share my screen with you. Let me show you this points better. Let me show you my exact. Okay. Now, can you see my screen now? I'm back to PowerPoint. I'm back to PowerPoint. Can you see me? Now, let's imagine that I have this one to be what? Exponential. I have this one to be, I have the first solution to be exponential 2x. That is the first solution, which is y1, right? If my y2 is exponential 2x again, if I should differentiate this one, I will have 2 exponential 2x. Are we together?
Yes, sir.
If I should differentiate this one again, I will have 2. Do you notice that in this case, by the time I find the determinant, do you know that I will get 0?
Yes, sir.
Now, if I get 0, what does that mean? It means that the two solutions, they are what? They are dependent. And if they are dependent, that means that the solution we are talking about is almost trivial. In the case of equal solutions now, if our y1 is this and our y2 is this, what we are going to get is linearly independent. But if we don't want to get, if we are looking for independent, then we need to multiply one of it by x. Are we together?
Yes.
Yes, sir.
So if we multiply one of it by x, you will now see that, let me put this one here. If you multiply one of it by x, you have something like this. You have something like this, isn't it?
Yes.
Then how do we get the derivative now? The derivative means that you keep 1. If you keep 1, let me do it. You give me 2x. Are we together? I'm using product rule. Then plus what? Plus what? You can tell me plus what? If I keep
Plus.
x, I differentiate exponential 2x, I will have this. Then if I keep exponential 2x and I differentiate x, what would I have? What will I get?
Yeah, 2x.
This is what I will get.
Exponential 2x.
Are we together now? If I keep x,
Yes.
I differentiate exponential 2x, I will have 2x exponential 2x. Then if I keep exponential 2x, I differentiate x, I will have 1. Now, in this case, do you know that this one, it can never be 0? Do you know? Are we all together? Do you agree with me? This one can never be 0. So that is what I'm talking about. So that is the reason why in the case of 2 equal roots, in the case of 2 equals root, we need to multiply one of the solution by the independent variable. So let's go back to what we're, so we are back. Can you see my screen now?
Yes.
So in this case now, you can see that you need to multiply one of the solution by what? By x, so that you can get a linearly independent solution. So let's proceed again. The third solution now is when our b squared is less than 4ac, and that is the case of what? Of complex. Then how do we write the solution? We write the solution to be what? Exponential alpha. In this case, alpha is the real. Are we all together?
Yeah.
Alpha is
Yes.
the real part,
Yes, sir.
then you now be exponential alpha multiplied by the independent variable. Then in the brackets,
Exactly.
a cos beta. Beta is the imaginary, the coefficient of the imaginary. That is the imaginary part. Then that is how to get the solution. So let's proceed now. Let's solve example number 1. Let's look at this now. In this case, we are asked to find the general solution of this one, which is homogeneous. But the question is this: we are giving condition. Now, looking at the condition now, is this initial value problem or boundary value problem? Hello, class. Is this initial value problem or boundary?
Bounded value, sir.
I disagree with you. You are wrong. Look at it again. Is this initial value problem or boundary value problem?
Initial value.
Yes, sir.
Initial value problem. You are giving that at t is equals to 0. Y is 3.
At y is
At t equals to 0, the y dt is 3. So it is initial value problem. So let's proceed and solve it. What do? We assume the solution. We assume A exponential E exponential mt. So you differentiate the first time, you differentiate the second time, you return it back to the problem. Okay, speak.
So I don't understand why this one is initial value, sir. Please, can you
Because
explain?
we have the two conditions. What are the two conditions? Y is 3, the y dt is 3. Both of them, they are given to us at y is equals to 0. Let me show you another way of writing this same expression now. The same expression, I will write it to you for you now. Now, can you see my screen clearly now?
Yes, sir.
This same condition here, it means this same condition, it's the same thing as y at t is equals to 0, then is equals to 3. Can you see my screen?
I can't see it. It is not good enough.
Can you see my screen now?
No, sir.
Okay, thank you. Can you see my screen now?
Yes, sir.
Now, that is the same thing with that problem, that condition. Then what about the second condition? The second condition means that y prime at t is equal to 0 is what? Is also 3. So look at the two now. You see that both of them, they are specified at 0. At t equals to 0. Can you see it now?
Yes.
So that means that it is indeed initial value problem. So look at this now. When t is 0, our y is 3, and the y dt is what? Is 3. So let's go and solve it now. We assume the solution to be a exponential mt. You differentiate the first time to give you ma exponential mt. You differentiate the second time to give you m squared a exponential mt. Then you substitute everything back to the problem. So when you substitute everything back to the problem, then you have this expression. You know that in this case, we can factorize a exponential mt. By the time you factorize, you now have 9m squared minus 24m plus 16. Then it's equal to 3. It's equal to 0. Then in this case, there are 3 things involved. Out of them, we are very sure that a exponential mt is not 0, because that is the solution we assume. But 9m squared minus 24m plus 16 is equals to 0, which is what we call the auxiliary solution, auxiliary question. So how do we solve this on quadratic? How do we solve it now? I will not speak on that, but by the time you use expansion method, you will see that this one is the same thing as 3m minus 4. 3m minus 4 is equals to what? 0. Then what does that mean? It means that my m1 is what? 4 over 3. My m2 is what? 4 over 3. So what is the solution now? The solution now is now what? A multiplied by independent variable plus b, then exponential 4 over 3t. Why do I need to multiply one of the solution by t? Because I don't want to obtain linearly dependent solution. Are we together?
Yes.
Because I don't want to obtain linearly dependent solution. Meanwhile, linear dependent solution, they are trivial. They are trivial. So now that's not all. Do you know that there's a problem now? We need to find A and we need to find B. Because what we obtain here is a general solution, not the particular solution. So how do we go about it now? Let's come back to the solution now. Next stage is for us to find A and B using the condition. And do that, we say that this is the what? Initial value problem. So let's start now. Number 1. Do not, this is our solution. Our solution is y of t is equal to at plus b, then exponential 4 over 3 multiplied by t. So what do we do now? Whenever you see t, you put 0. Are we together?
Yes, sir.
Whenever you see t, you put 0. So that will give you y of 0. Then a, t times a will now be multiplied by 0, then plus b. Then here, you know, we have 4 over 3 multiplied by what? 0. Then anything raised to power 0 is what? Is 1. So here, you now see that your b is equal to what? 3. Is there any question on this? Okay, let's go and use the let's go and find the second constant now. Before we can find the second constant, we need to differentiate the solution. Now, if you look at the solution very well, I think, do I need to explain how to differentiate this? I don't need to explain. No. Hello, hello, class.
Yes, sir.
Do I need to show you how to differentiate this?
No, sir.
No, I don't need to show you. I believe you can differentiate it. So, eh? Hello? Do I need to show you how to differentiate this?
We can differentiate.
I will not differentiate. I will not.
We can differentiate it, sir.
I will not. I will not to show you. So if you differentiate the solution, this is what we have. Do you know the reason why we need to differentiate? We need to differentiate because the condition we are given, it has to do with derivative. So before you can find the second one, you need to differentiate the solution with respect to t before you can set t to be 0. So when you differentiate, this is what you have. So wherever you see t, you take it to 0. Then you now have a times 0 plus b, then 4 over 3, then exponential 4 over 3 times 0 will give you 0, then plus a exponential 0. Then if you look at the 0, you now see that this is the same thing as 3 is equal to 4 over 3b plus a. Do you know that we've already obtained our b to be 3? So you substitute your b to be 3. So in this case now, you see that 3 will cancel 3. Then 4 will go to the other side. Will now give you minus 4 plus 3. That a is what? A is minus 1. So this is the final solution. Any question on this? So let's proceed. Eh? Please come again. Come again. Please come again. Let me hear you clearly.
That person.
Okay. In that case, I will need to mute everybody so that I can. Okay. Now let's proceed. Let's proceed. Let's now start the real problem now. We want to start solving the problem that is non-homogeneous. There are 3 cases here. So there are 3 cases here. Number 1, when our f of x is a constant or is a polynomial. What do I mean by constant? Look at an example now. Look at an example. Here, our f of x is what? 4. Hello, everyone. Look at this case. Hello, everyone. Can you hear me clearly?
Yes, sir. We can.
In this case, what is my f of x?
4.
Now, you see that this is what? This problem is what? Is non-homogeneous. Do you all agree with me?
Yes, sir. Yes, sir.
Now, let me show you another problem again. Look at this one again. What is my f of x?
9.
And this one is what? Non-homogeneous.
Non-homogeneous.
But we see that in this case, c is 0. There's nothing like c, there's not like plus cy here. Do you notice? But look at this very well. You know, we are supposed to have y here. Hello, everyone. Can you hear me clearly?
Yes, sir.
In this case, you notice that something is missing. Do you notice?
Yes, sir.
Okay.
No, sir.
Now, let me show you another example again now. Another example now is this. Look at this problem now.
Yes, y.
In this case, there is plus 12y. And if you look at the non-homogeneous part, the non-homogeneous part is in terms of what? Is in terms of polynomial. Are we together?
Yes, sir.
Yes.
So those are the three cases here now. So those are the three cases that we have under this problem, under this one now. So that's I said that. I said in this case, our f of x is a constant or is what? A polynomial. So let's solve example 1 now. In example 1, I think the first thing we are going to do is this. We first of all look for what is called the complementary part. For us to get the complementary part, we assume that f of x is what? Is 0. Are we together? So if that is the case, then we can now say that we can assume our solution because we need to first of all solve the complementary part before we now look for the particular solution. So in this case now, we assume our f of x to be 0. Are we all together?
Yes.
So if you assume your y is equal to AMX, then you differentiate twice, you substitute back to the problem, then you solve the auxiliary, you see that you have M1 is 1, and you have your M2 is what? -2. So in this case, you know that this is the case 1 now. This is the case of b squared greater than what? This is the case of what? B squared greater than what?
4AC.
4AC.
4AC. And what is the solution? The solution is what? A exponential m1x plus b exponential m2x, which is the solution. So let's proceed now, solve. Look at this next step we're going to do now is this. You know, in this case, our f of x is equal to what? 4. Are we together?
Yes, sir.
So because it is equal to 4, and you know that 4 is a constant, right?
Yes.
So we are going to say that let v equals to k. Another reason is this. If you look at the solution, you notice that there is no constant in the solution. Look at it. You know that we're having a multiplied by exponential x, and exponential x is what? Is a function of x. Look at this one again. We're having b exponential -2x, and this is another function depend on x. So we are going to say that let our v is equal to k. Why do I say v is equal to k? There are two reasons. Reason number 1 is because my f of x is what? Is 4. Reason number 2 is that y of c, which is the complementary solution, it does not have any constant. Are we together now?
Yes, sir.
It does not have any constant. So that is another reason why I say that my b is equal to k. Now let's go back. Do you know that the auxiliary solution is the same thing as this expression? Look at it. I think I explained to you the other time. Because, you know, here, if you factorize, y is the assumed solution, right? Which is EMX. So this method here, we call it D operator. So this one will now give me D squared plus D minus 2 into bracket y is equals to what? Is equals to 4. So the next thing is this. I'm going to change my y equals to v equals to k, isn't it? Then I can write the same expression. I change this one to be k because k is a constant. Now, what is the next thing now? It will expand. I will expand. I will now have d squared multiplied by k plus d multiplied by k minus 2 multiplied by k is equals to what? 4. Now, k is a constant. If I differentiate constant twice, what would I have?
0.
Now, everybody take note of this. D here is the same thing as the square over the x squared. Let me write it down. Let me write it down so that you can see. Okay. Now, everybody see my screen. Can you see my screen now?
Yes,
Can you
sir.
all see my screen? Okay, thank you very much. So, what I'm trying to explain to you now is the fact that I'm having D here. This is my D. D is equals to this. Are we together now?
Yes.
If that is the case, then what about D squared? So I will have my d squared. I will have my d squared to be equals to second derivative. So in that case, I will need to differentiate k twice. Can you see my screen now?
Yes, sir.
So in this case now, you will now see that the problem we are solving is now in terms of we are having it to be d squared, then plus, and that is actually plus d minus 2, then everything in a bracket. Everything in a bracket, then multiplying by k, then is equals to 4. So which means that this expression is still the same thing as I can put this one here. So I will now have this one to be will give me, okay, will give me this one here, then multiply the derivative of k. So that means that I'm to differentiate k twice. Then in this case, I'm to differentiate this one once. In this case, I'm to differentiate. So I'll have my k here. No.
Okay.
I'll have my k here. I'll have my k here.
Yeah.
So if you look at this very well now, you now see that if you differentiate k, and k is a constant, if you differentiate it twice, it will give you 0. If you differentiate this one too once, if you differentiate constant, it will give you 0. Then what we now have will now be, everything here minus k, 2k is equals to what? 4. Then what is k? K is what?
2.
K is minus 2.
Minus 2.
K is minus 2. So that is how we obtain k equals to minus 2. Now, in this case now, we already have our complementary solution. This is our complementary solution, which is a exponential x plus b exponential minus 2x. Then what is our particular solution? Our particular solution is what? Is minus 2. Then what is the general solution? General solution now is the addition of complementary solution and particular solution. So this is the final solution. So this is how to solve homogeneous equation if the non-homogeneous part is a constant. Let's solve another example now. Look at the problem we want to solve now. Okay, can we all see it clearly now? This is another case. In this case, let us assume our solution. Let's return everything back. Then what we have as the auxiliary will now be m squared minus 3m is equals to what? Is equals to 0. In this case, you know that m is 0 and m is equals to what? 3. And this is also the case. Yeah, what's your question?
So is the complementary part of the equation always given?
No, we only set f of x to be 0 in order to obtain the complementary part.
Okay.
So for the complementary part now, you change 9 to 0.
Okay.
If you look at the first case we solved, for us to solve the complementary part, we change our 4 to be 0.
Yes.
So now if we now get the complementary part now, we change our 9 to be 0, then we have, that's how you can see m squared minus 3m is equal to 0. So if you solve this one quadratically, you see that m is 0 and m is 3. And this is the case of real and distinct. So how do we get the solution? We now say the solution, which is the complementary solution, now is now what? A exponential 0 plus b exponential 3x. But do you know that anything is 0 is what is 1? So this means that what we are having here is a solution in such a way that this is a constant. Balogun Said, please take note of your side. So, Balogun Said. So are we together now? So now let's go back and and look for the particular solution now. You know, in this case, f of x is what? Is 4. Hello, students. Are we all together?
Yes, sir.
Yes,
F
sir.
of x is what? F of x is 4.
Oh.
But there is a constant in the complementary solution. Do you notice that? Look at it.
Yes,
Look
sir.
at it. This is a constant. Everything is a constant. A exponential 0 is a constant. So because we have a constant in the complementary solution, we are going to assume our v to be a function multiplying the independent variable x. Are we together now?
Okay.
The reason is this, because f of x is a constant, number one, because there is a constant in the complementary solution. So we are going to assume our particular solution to be a function multiplying by x. Can you see now? So that is the second case. So what is the next thing I'm going to do now is that I will go back to the same method again. I will now say that this method, we call it the operator. So that means that I will have d squared minus 3d. Do you know the reason I get this? Look at this one. You know, here, if you factorize y, what you now have is what? D squared over dx squared. If you factorize y, so that is why. So y here is the same thing as kx. Are we together now? Y here is the same thing as k multiplied by x. So what's the next thing? We expand. So ks will come and meet d squared. Ks will come and meet minus 3d. Then will give us this. Now look at this now. If you differentiate kx with respect to x twice, what will you get? If you differentiate the first time, you get k, isn't it?
Yes.
If you differentiate the second time, you have 0.
0, yes.
So you have 0. Look at this one again. If you differentiate kx with respect to x once, you have k. So you now have minus 3 times k is equals to 9. If minus 3k is equals to, then what is k? K is what? K is minus 3. So you can now go back to your y particular now. See, look at this. Look, I have said this might be here. It's same thing as y particular. Please take note of that. So that will give me minus 3. So look at it now. I have minus 3. So what's the final solution now is that this is the complementary solution, right?
Yes.
This is the particular solution. Then I'll add them together. Then this is the solution I'm talking about. So that is how to solve non-homogeneous. If, number one, f of x is a constant. 2, if f of x is a constant, but the complementary solution has a constant. Let's go to the third case. This second case here, we call it slug. There's a name they call it slug. Do you know they call it slug in the sense that in the complementary solution, there is a constant. So if it is a case of slug, then you need to assume your y particular to be k times x. So let's go to the third case now. Under the problem of f of x, non-homogeneous part. In this case, the non-homogeneous part is a polynomial, and the polynomial is of order 1. The polynomial is of order 1. So now look at this now. This case, my f of x is 3x minus 2. Now, firstly, we shall consider the complementary part. You know that the complementary part will let us know the kind of particular solution we should assume. So let's go back to the problem. Now, in this case, now look at my assumed solution. Do you notice that in my assumed solution here, I didn't write A. Look at it. Can you all see there? I said, let's seek the solution to be exponential mx is also correct. So if you put everything back to the problem, can you all hear me clearly? Hello? Can you hear me? Hello? Hello, can you hear me clearly? Hello, can you hear me clearly? Can you hear me clearly?
Yes, we
let's
can hear you,
Yes, sir,
sir.
we can hear you now.
Okay. So I think I need to share my screen again.
Okay, NEPA to the light.
No, not at all. I just the thing, it was a kind of disconnection.
It's network.
Maybe network problem. So I just need to use. Okay, are we continue now?
All right.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes, sir. We can continue.
So I'll need to. Can you? Okay, you can see my screen. So now let's proceed now. So in this case now you see that by the time you differentiate, you put it back to the problem.
Yes,
Yes,
sir.
sir. Go ahead.
2m squared minus 11m plus 12 is equal to 0. So in that case, we can have a kind of 2m minus 3m minus 4 that is equal to 0. So I don't need to extract this quadratic equation, but I think I would advise you, please go and learn how to solve quadratic equation at this stage now. You need knowledge. So here, my m1 is what, 3 over 2, and my m2 is what? Is 4. So what is the complementary solution now? The complementary solution is what? A, then exponential m1 multiplied by x, then plus b exponential x. So we need to proceed and solve for the particular solution. But don't forget that here, the non-homogeneous part is what? 3x minus 2. Now, I even write it down for you. Can you say here that d is equal to d over dx, and d squared is what? D squared over x squared. So if that is the case, then my y particular now.
Hello, sir.
Hello, I can hear you. Ola Deborah.
Yeah, can you please, why did you have the first D over there?
Is the same thing, is the operator method.
Oh, okay.
The D operator method. But if you look at it, it's not special. Because I just go back to the same problem. Are you getting me now? Are we together?
Yes,
Go
sir.
back
Yes,
to the
sir.
same problem.
Yes, sir.
Then instead of writing d square over dx square, write it at d square and d. Are you getting now? Then
Yes.
thereafter, you factorize y, isn't it? Then by the time you
Yes.
factorize y, then you can call it y particular. So, but in this case, before you can proceed, we need to assume a particular expression. Because our non-homogeneous part, 3x minus 2, we are going to consider a particular solution in form of ax plus b. Look at it. I only form in terms of the non-homogeneous parts. Are we together now?
Polynomial.
So
Yes, sir.
instead of writing yp now, let me now change it back to what I assume, which is ax plus b. So what's the next thing now? I expand. 2d squared multiplied by ax plus b minus 11d multiplied by ax plus b plus 12 multiplied by ax plus b. Look at this one now. This one means that I will need to differentiate twice. So
Okay, yeah.
I would need to differentiate twice. So if you differentiate ax plus b the first time, you have a. Because b is a constant, it will disappear. Then x will reduce to 1. Then you have a. If you differentiate the second time, you are not differentiating a. It will go. Then you have 0. Then you now have 2 times 0. Then let's come back to this place now. We have minus 11. If you differentiate this one once, with respect to x, you have a. So you have minus 11a. Then, if you expand 12ax plus b, it will give us 12ax
Plus LB.
If that is the case, I think we are good to go. We are going to use we are going to equate the coefficients now. How do we equate the coefficients? Look at it. Minus 11 times a, 12a multiplied by x, 12b, then is equal to 3x minus 2. So if we have to equate the coefficient, do you know what we take? We take 12ax is equal to what? 3x.
Yes.
We are only picking the one with x. So in this case, you know that x will cancel x. Then what is a? A is now what? 3 divided by 12. So we have our a to be 1 over 4.
1 over 4. Okay.
Let's go back to the expression again. This time around, we are going to pick minus 11a plus 12b is equal to what? Minus 2. So in this case now, before we can solve this, we need to substitute our A equals to 1 over 4.
Yeah.
By the time you return 1 over 4 here, then you make B the circular formula. You have your B to be 1 over 16. So what is the Y particular now? Y particular is not the same thing as AX plus B, which is what? 1 over 4 multiplied by X, then plus 16. So you can add it together now. Now add the complementary and the... So that is how to solve this third case. Now, you can now see now that we are through with the case of constant and polynomial. Look at it now. The case of constant and polynomial. If you remember, in our WhatsApp group, I sent a particular textbook to us.
Yes.
Yes, sir.
Okay. If you look at that textbook, that is actually what I'm using now. And you will see clearly now that it contains, that is on page 470 something, 475. Let me tell exactly. I get it right. 475. I go to page 475. So let me share my screen now. Can you all see my screen now? Bele? Who is that?
It does not be. It does not be.
Are you all see my screen? Can you all see my screen?
Yes, sir.
Yes, sir.
Now, that is the textbook now. So all of you go back to page 474. You will see it. So let's now go to chapter 51. In chapter 51, you now see what I'm explaining to you, sir. Look at it now. Chapter 51, you see now that the case of non-homogeneous, can you see now?
Yes, sir.
The case of non-homogeneous. So this is the first case that we are trying to study now. This is the case where f of x is a constant. Look at it now. Can you see a table now? Can you see a table?
Sir.
Look at the table.
Yes, sir, we can see.
The table, f of x is equals to constant.
Constant.
Then look at it, straightforward cases. You only change your particular solution, you assume K. But in the case of snag, do you remember the case of snag? Hello, class. The case of snag, that is
Yes,
when there is a constant in the complementary solution. Are we together? Are we together?
Yes, sir.
Yes,
sir.
So that is what we are to use. So you can see the table there. So
Yes,
if you now
sir.
scroll, so you now
Yes,
see other table. Look at it. You see other things that we need to put into consideration. So this is the case that we've just solved now. So everybody, you now go back to this textbook. You will now go and study the whole chapter 51. So
okay.
if you are through with the chapter, then I think everybody should finish the chapter between now and Wednesday. Between now and Wednesday, go and study the chapter. You see so many. In fact, is there anyone that checked this textbook very well? It's very explanatory. They explain everything line by line. So everybody go and study chapter 51 between now and Wednesday. Then I will post our classwork. So we are going to call it a day here. Thank you very much for coming. But before we go, is there any question?
Sir, there's a question. How did you get ax plus b as in for the last polynomial? Or is it a constant?
Yes, I'll zoom it. Look at it.
Yeah.
Because it's a
Yes.
polynomial. Look at it. Look at it. Look at this, my screen. F of x is a polynomial.
Okay.
That is, so because, in the problem, the polynomial is actually, we are given the problem, the differential equation is 3x
3x plus 2 minus 2 or so.
So
Yes.
our f of x, we are given 3x minus 2. So we are going to assume a polynomial of the same order. That is why we assume ax plus b.
Okay.
So let's assume that we are solving a differential equation and the non-homogeneous part. Non-homogeneous part is actually quadratic. So what are we going to assume? We are going to assume as squared plus bx plus c.
Okay.
So that's what we're going to assume as our particular solution. So by the time we use that one, then we refine it. Then we get a perfect particular solution.
Thank you, sir.
Now, before I go, look at the case of exponential. Look at C. The case of exponential, that is if the non-homogeneous part is something like exponential 5x. What are you going to assume? You are going to assume k multiplied by exponential ax.
Yes. Okay.
So don't let me talk much on that. Is there any question again?
Yes, sir.
Yeah, what's the question?
So it's not even question. It's about I just want to, I want to say this on behalf of others.
Okay.
So I don't know if you are aware about our PMA.
Okay. When are you starting?
So it
When
was
are you-
recently closed. It was released about many weeks ago. Now it was recent. It was closed. It was in midnight today.
I
And
hope you responded.
normally it's not supposed to have
It's not
closed.
responded.
See,
Yeah, it's not supposed to have closed because we're given.
Yeah,
It was not
please go to your study center. Go to your study center and log the complaint.
I think they say they are maintaining the
Yeah,
site
lay your
also.
complaints. Lay
They
your
are
complaints.
maintaining the site now. The site is under maintenance now.
Just have to be sure so I won't just wait till
Exactly. So it's confirmed that the site is under maintenance.
Okay.
So, is there another question again?
Sir, there
No
is question,
question,
sir.
sir. We love you,
That was
sir.
your question.
Hello, sir.
I can hear
That's
you.
okay.
Sir, please. I came in into the lecture 45 minutes. 45 minutes into the lecture,
you are
please,
late.
sir. I will be very glad if the if the video is uploaded as soon as possible,
I
so
will do
that I'll
that.
be able to.
I will do that. I will do that. I will do that.
Thank you, sir.
I will do that. Is there another question again? Any contribution?
I have something to say, sir.
Okay, read one.
Sir, sorry for disturbing you, sir. Sir, we are having problem in one of our one of our courses, sir, because there is no facilitator for that particular course.
What is the course?
I think MTH232.
What is the course?
Vector.
What's the course code?
Vector, sir.
Please go and download the nice textbook. Even you can check this textbook, you can see one or two things on it.
A lot of people are having issue on that particular thing.
I also have my own issue too. I have my own issue.
Sir, with you by our side, we believe no shaking, sir.
I have my own issue.
This is another one.
Next question, please. Next
Sir,
question.
please help us out.
Ekalesa.
Where is that?
Ayenade Tomesi. Oh yeah. Speak.
Sir, I want to say thank you, sir.
Thank you very much.
And I want to say that you can still help us because I want to read one is saying.
I cannot help you. My school, in my school.
Hello, sir.
Hello. In my school, we've resumed. In Futa has resumed. So our students are back today.
Congrats, sir. Congrats.
So I'm going
Hello,
to.
sir.
Hello,
sir.
Mhm.
Hello,
Sir,
sir.
please, I have a question.
We are speaking.
Hello, sir.
We are speak now.
I want to make a request, sir.
What is it?
The request is when the timetable is out, probably towards the start of this particular course.
What timetable?
I mean the exam.
What timetable?
Sir?
What timetable?
The exam timetable.
Okay.
Please, I want to plead for a kind of revision.
I'm sorry.
Yes.
I will only I direct you back to my videos.
Okay, no problem. Okay, no problem. That's good.
Sir,
If
based on the exam, that's my complaint, sir.
See, by the time we resume, you also pity me. It's not always easy.
So,
This has to do with differential equations too, based on my last experience.
Okay.
The way they said differential equation is kind of confusing.
Okay.
They use figures that are not even related to the differential equation. I hope it will not happen in this course also.
I will lodge the comment to the HOD. I will lodge their complaint. I will explain to the HOD of mathematics department.
Thank you, sir.
Thank you very much, sir.
The person is Mr. Disu, Mr. Akim Disu, Dr. Akim Disu. That is his name. So I will contact him.
Thank you very much, sir.
Okay, so thank you everyone. So please, you are to study chapter 51 between now and Wednesday. Then I will
okay, sir.
my classwork.
Okay.
Okay, sir.
We'll do that.
So thank you
I
very
will
much.
start tonight.
Okay, thank you for coming.
Thank you, sir.
Okay, thank you.
Thank you very much for your time.
Okay, you're
Regards to your
welcome.
family, sir.
Thank you,
Okay,
sir.
thank you very much.
I'm
Thank you very
sorry.
much.
My family, we are supposed to
Bye-bye,
watch.
sir.
I'm sure they will be as bright as you, sir. I said, I'm to your students. I'm
Definitely
very sure
now.
they'll be as bright as you.
Thank you very
Definitely.
They
much.
are
Thank
very
you.
lucky to have a kind of bright teacher, lecturer like
Thank you very much. Thank you very much. Thank you very much.
Thank you.
Actually, the reason why I accepted it, they don't pay me. I just accepted because I learned. They said there are some students that they are interested to know. They said, although they said they are promised to pay, but it's a very long time something. But when I learned that, they said the group of them they are interested to know. Okay, fine, no problem. But to my surprise, in our WhatsApp group, with
Sir,
what I'm
aren't
seeing
we?
there,
I want to know more.
you notice I didn't send any video this time. You notice I didn't send. I'm supposed to send
Yes.
today's class.
Yes.
It is well. So thank you very much. Thanks for coming.
Thank you so much. Sir.
Thank you very much, sir.
Thank you,
Bye-bye.
sir. All right.
Bye-bye.
Bye-bye, sir.
Yes, sir.
I am
Okay, bye-bye, sir.
Bye-bye, sir.
Okay.
Thank you,
bye-bye.
sir.
Okay. Thank you.
Okay, bye-bye,
Okay.
sir.
All right. Bye-bye,
Okay,
sir.
Bye-bye.
Okay, sir.
Bye-bye.
Okay. Thank you. Thank you.
Monday.
Okay.
Look at you.